Hey guys, and welcome back to another GCSE Maths Grade 9 exam question, and today we're looking at another circle theorem proof. So this is the third one of our proofs now for the circle theorems, and this is the same segment theorem. So what this is saying is that this angle here, for example, and this angle here would be equal, and then the same with this angle here and this angle here. And this is quite a nice proof. It's very quick actually, so we can do it quite quick. So I call this A. And I'll call this B. Obviously, if we call the centre O, right, what I'm going to do is I'm going to join just an extra two lines here. So I'm going to join from A to the point O, or the centre, like that. So it doesn't look perfect. This should really be straight, but I'm doing it freehand, so it's not going to look perfect. And I'll do it again to B. Now, this is my centre O. So, anyway, I also call these 2 points C and D. So we've got the points labeled so we can see clearly, and this is a format question just so we're not confused. What we've got to do now is give this angle here a name. So I call it X, and the reason I'm joining this line here is to show these two lines to show something important, and it uses another theorem that we've already proved, and that is the idea that the angle at the center is double the angles at the circumference here. So if this one here is X, so if I just wrote this out actually, I wrote this out, just gets in the way a bit. Oh, what's going on there? Oh no, what's going on? I'm making a mess of it. Right. So hang on, let me just do this again. So I've got my point here. If I call that angle X, what this means is that this angle here would be half of X, right? Because if this was 90, for example, this would have to be 45, because remember, angles at the centre are double the angles at the circumference. So if this is X, this must be X over 2. That's X over 2. And then same again, if you look at this angle here, so you just imagine you've got this angle X here and this angle here. This angle here, X, is double this. So this must also be X over 2. So it looks pretty clear now that these are clearly the same, because X over 2 is X over 2. But let's put it in a bit of a mathematical term. So what we're going to say now is that angle AOB, so that's AOB, so AOB, we're going to call that X, so that's X. Now what we can say is that the angle ACB, so ACB, is X over 2. So ACB, that's X over 2. And the reason we know this is because of what we just said before. So the angles at the centre are double the angles at circumference. So this is X, this must be X over 2. And then we can also say the same for this angle here. So angle ADB even, ignore me, A, because we're going from A to D to B. So this is like this angle here, ADB. Sounds like D, believe it or not, it's very poorly written. ADB. This is also X over 2. And therefore, these are equal. So because these are equal, we've proven that the angles in the same segment must be equal. And you could also prove it using these two angles here as well. So I hope that's okay. It's one of the quickest proofs for the circle theorems. There's nothing too intense going on, but if there's anything unclear, guys, be sure to drop a comment below.